everyone, today we are going to be talking about how to find a missing data point when we are given the mean as a balance point for a set of data. Now I'm giving you a video on how to do this because we haven't had one so far. After this example, I would like you to try problems number 2 and 3, which have you trying this, and I've added some boxes and some lines to help you work through the problems. When you send it to me, I'll give you some feedback so you know how you're doing. So problem number 4 says the following dot plot shows the number of pets owned by 10 different students. Where would the 11th data point need to be for the balance point to be 3? And we are going to place it on the line plot. So we have 3 key numbers here, 10, 11, and 3. So we can see here that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different students. And we need to add 1x somewhere on this plot to have 11 total. And we want the balance point to be 3. So this problem is not asking me what is the balance point. It's asking me where that data point would be to make the balance point 3. So I'm going to start by placing a line at 3. We talked in the last video about how when a number is the balance point, the sum of the distances below the balance point are equal to the sum of the distances above the balance point. We don't need to worry about the x that is on the 3 because it is already on the balance point. So looking at below 3, I have 1, 2, 3. I have 1, 2, 3, 4, 5, 6 x's. So I know that I need to add up 6 distances. And these boxes are just to help me keep track of the different distances. So this x is 1 away from the balance point. This x is 1 away from the balance point. And this x is 1 away from the balance point. Some students get confused because they're stacked, but remember that all of these x's represent the number 2. This x is 2 away from the balance point, and this x is 2 away from the balance point. Finally, this x is 3 away from the balance point. So we're not adding the actual numbers that the x's represent. We are not adding up 0, 1, and 2. We are adding up their distance from the balance point, 3. So that's why we don't see any zeros here, and that's why we see a 3 here. So we need to find the sum of those distances. So 1 plus 1 plus 1 plus 2 plus 2 plus 3 is equal to 10. Now let's look at the sum of the distances above the balance point. We have 1, 2, 3 x's. So I know that I'm going to need to add together 3 distances. So this x is 1, 2 from the balance point. This x is 1, 2 from the balance point. And this x is 1, 2, 3, 4, 5 away from the balance point. The sum of those distances is 2 plus 2 plus 5, which is equal to 9. Now for the 3 to be the balance point, the sum of the distances has to be equal. Well, 10 is not equal to 9. We need to think, how many more do I need to add to 9 to get 10? Well, I would need to add 1 more. That does not mean we are adding an x to the 1. It means that we are adding an x that has a distance of 1 from the balance point above the balance point. Well, if I start at the balance point and I go 1, I would put an x here. So that's my final answer. The answer to this question is 4, because that is where I would need to put that 11th data point in order for the balance point to be 3.